Welcome to the Will the Orange Guy Arduino Code project on GitHub. This is an archive of code for each day's Arduino projects. So you can sponsor the project here, and because the language of Arduino is actually based off C++, GitHub records it as 100% C++. It's a public archive because the class is done. This was grade 9, I'm no longer in grade 9, and so there's no longer any code being added to the project. As we scroll down the page, we see our Arduino code page here with key features such as code for Bluetooth libraries, infrared response libraries, and BattleBot codes. You can download the source code to run it on your own Arduinos. It's built in partnership with GitHub and the Arduino project and their tools, and licensed under the GNU General Public License, which the project repository contains the license file, which can be accessed by clicking this link. If we scroll back at the page, we can see our code here. So starting, there's one program that follows the lines on the page. So it would define the I/O pins and the input tracking pins, and you can see those here. It would read them and defines which motor would drive which way. So then there would be a forward function, a back function, a left function, a right function, and a stop function, which would use either high or low to turn the motor on or turn the motor off as well. Each of these would print to the serial what they were doing, so stopping, going right, going left, so on and so forth. So we would start and run the command and put it in this port, and then the program would run. If it was black, it would go, it would stop, and then it would go back a little bit. Otherwise, it would go forward. Now there's also a motor control function here, which has this motor truth table here. So if the ENA, IN3, and IN4 are the specific functions, the specific things would happen to the motor. So example, if ENA was low, the motor would be off. If ENA was high, but the individual motors IN3 and IN4 were low, they would be stopped, it would be on brakes. If the ENA is high, but IN3 is low, but IN4 is high, then the motor is on and turning forwards. Otherwise, if it's the opposite, the motor is on turning backwards, which makes sense. And if all the functions are high, the motor is stopped and on brake as well. So each of the pins is put in here for the right wheels to turn the car the right way. And so we set up our pins. And our main code is here, turning the right wheel forward. Then the right wheel is stopped. Then we turn the right wheel backwards, and then the right wheel is stopped again. Now this program here has the exact same truth table, just now with more motors. I'm not going to go over it again, but the purpose of this program was to create a planter, as if this was a robotic farm equipment. So it defines each of the pins, as well as whether it's going forwards, backwards, left, or right, based off the data in this truth table up here, and has our setup thing to function each of the pins the way they should be, as well as running through this thing to paint rows on a piece of paper, making it look like it was a planter. So it goes forward, then right, then forward, then right, then forward, then right, then forward, then right. So turning up and down in rows, each of those delayed by this specific function here. Now these delay times are arbitrary to the size of field we were using. However, you can use this and customize it to make it work in your own project. Heading back here, we go to our BattleBot program. So this was our original BattleBot that we created. And it reads the pins, assigns all the pins, assigns all the car speeds, and then would check how far away something is using the IR sensor, and then go for either forward slow, forward fast, back, left, right, stop. And then it also had an attack function where it would go forward first, and turn right, and go forward slow, and then go forward really fast, printing to the serial that it was attacking. Also had a retreat function where it could go back, turn left, go forward a little bit, and then go back, also printing to the serial that it was retreating. And it also had a reposition function where it would go back, delay, go left, go forward, delay a little bit more, go right, delay some more, go forward, delay some more, go right, delay some more, and attack, and then print the program status of repositioning to the serial. Now on loop, in order to do our attack, it would attack, and then if it was outside of the BattleBot ring, it would move away from there, which has all of these functions here to show it that, as well as it would just basically move through the whole entire page and the whole entire BattleBot arena, attacking or retreating, unless, of course, it reached the black, in which way it would back away. Now that was a more complex version of the project. We can move over here to our simple version of the project, which we named our BattleBot Simp. And what it would do is control the servo motors in the exact same way, getting our distance, slow forward, fast forward, back, left, right, stop, attack, retreat, reposition, similar to that. And basically what it would do is it would move forward very fast, delay, and then it would back up, hopefully not hit the black, move forward again, attack, reposition, retreat, so on and so forth. Heading back now to the main page, we can see our Bluetooth. So when we attempted to control it with a Bluetooth command, so this would pull in the IR remote and the servo motors and pull in all of these keys, all of these motors, so that way it could be controlled by Bluetooth, as well as doing line tracking and have an LED. So this code here is more arbitrary for the Bluetooth, but it would be able to get distance, move forward, move back, move left, move right, stop, turn left, turn right, get Bluetooth data using this function. So depending on what button was pressed in the Bluetooth app, it would either go forward, back, left, right, stop, or turn left, turn right. And it could also do that with the IR remote by going forward, back, left, right, stop, or with other Bluetooth modes here and the IR remote modes here. Now, it had many line tracking modes as well as it could avoid obstacles. And then everything is set up, the pins are aligned, and they're done here, and then it loops through all of this code here. Scroll back up to the top, back to the main repository, and we can see the IR remote code, which is here. And so it defines all the pins, as well as bringing them in, bringing the LED and bringing the serial part in, and then using the IR remote, as stated before, to move the robot and receive individual values. So if you are in an Arduino class and you feel like you might be benefited by any of this code, feel free to fork or start the repository and download the code so you can get started on it on your own.